Hello. If you're watching this video, that means you want some extra help with the questions. So you're looking at these two examples. Now this one, example 2 on the same note. How much energy is needed to boil 3 kilograms of water at 25 degrees Celsius to steam? Now what does that mean? That means you only need the water to go to steam. You don't need to bring it up to any higher. Now, for example, if you go back and take a look at the heating table, that means you have something that starts with water and you just want to bring it to steam, right? So now let me clean this up so that I can use the same page. Okay, so there we go. So where are we? So we want to bring water, 3 kilograms of water from 25 degrees Celsius, which is around here, right? 20 is here, 25 degrees Celsius is here, and we just want to bring it to steam. That's it. We want to end right here. That's steam, right? Oh, actually, I am so sorry. We are bringing it to here. Okay, so that's 3 point right here. So at the beginning, we're at 25 degrees Celsius water, liquid water, right? So this is liquid. And then we're going to go to 100 degrees Celsius because that's the boiling point of liquid water. Now, so in this process right here, we are going to need some change in temperature. So change in temperature, remember? So change in temperature, which means we're going to use MC delta T, right? So change in temperature, we use MC delta T. Now then we need a phase change. Okay, so we need a phase change. Now for this phase change, it's going to happen here. So then we get steam, right? So we get steam at 100 degrees Celsius right here. So that is going to require what? That's going to require a phase change. And a phase change requires which equation? So this one requires the mass times latent heat. Now, previous example, we have dealt with melting. This one is actually boiling. So please use the vaporization portion of the formulas, right? Of the table on the formula sheet. So this two step. Now, it didn't say that we have to bring the steam to any higher temperature than 100, so we stop at that. So only 2 steps, quite easy. So let's do it. Number 1, okay, so step 1. So step 1 right here is going to be liquid water. So we're going to have 25 degrees Celsius water going to 100 degrees Celsius water. Why 100? Because that's the boiling point. If the boiling point of water is 150, I'll go to 150. But right now it's 100. So that is a change in temperature. So MC delta T. Okay, so now we're talking about liquid water in here. So the mass, 3 kilograms. So liquid water, the specific heat is the number that we very used to, 4,186. That is from the specific heat table, right? The one that you used last week. And the change in temperature from 25 to 100 is 75 degrees Celsius. Okay, so then you get that in the calculator. You should get about 941,850 joules. So now step 2, very quick. So step 2 is we need to bring that water into steam. So it's 100 degrees Celsius water into 100 degrees Celsius steam, which means we're changing phase. From liquid to gas, right? So changing phase from liquid to gas. So that is going to be heat of vaporization. We're vaporizing the water. So this one is easy. So it's going to be 3 kilograms. I don't know how much energy do I need to liquefy, make the water into gas. So I go to a table. So table up front. So this is a latent heat table. So that we cancel everything in here so that we look at it as fresh as we possibly could. So water, this column right here. And we want boiling. So we look at boiling temperature is 100. And how much energy do you need to boil it? Right here. So which value is that? Right here. So 2256. So how much energy do you need to boil a kilogram of water? 2,256. But remember that number is missing 1,000. Right, all these numbers multiplied by 1,000. So that is actually 2,256,000 joules of energy per kilogram. Okay, so let's put it down here. So now we're back to the example, and we're gonna put the latent heat value here. So we did 2,256, but the number is missing 1,000. So add 3 more 0 joules of energy per kilogram. So do that will get you about 6 million, almost 7 million joules of energy. So to boil water into steam takes a lot of energy. Now, then we're done. Add the two values together and bring it to some reasonable sig fig. I'm going to use scientific rotation. It's about 7.7 million joules. Okay, so that's it for this question 2.